Okay, I want you to picture a scenario. It's a Tuesday morning, rainy, typical rush hour. You're walking down a busy street, head down, dodging umbrellas, maybe you're late for a meeting. You look down at the pavement and you spot a wallet. It isn't just lying there, it's practically glowing, it's bulging. You pick it up. Inside, there's a stack of cash, let's say $500 plus credit cards and ID. You look around, no one's looking, no security cameras. In that split second, your heart rate spikes and you make a decision. You grip the wallet, you turn, and you chase after the person who just turned the corner to give it back. Now, here's the question I want you to answer, and I want you to be brutally honest with yourself. Why did you do that? Was it your ironclad integrity, that carefully cultivated character you've been building as an adult? Was it because you are, deep down, a good person?
It's a comforting thought, isn't it? We absolutely love to believe that we're the captains of our own ethical ships, steering by the stars of our values.
Exactly. I like to think I'm a good person because I choose to be, every day. But today, we're going to completely dismantle that assumption. We've got a stack of research here that suggests that character, that thing we prize so highly, might actually be the least important factor in that decision.
It's a confronting realization. I mean, it goes against our entire intuition about who we are.
Confronting is putting it mildly. Today, on the Deep Dive, we're unpacking a fascinating and, frankly, slightly unnerving new paper. It's titled Neurodevelopment in Early Childhood and the Emergence of Moral Cognition by Toronata, Tambun and colleagues, published just this year, 2025.
And the mission today is to follow our guiding philosophy. Decompose and distill. We're going to take this incredibly dense neuroscientific model and, well, break it down. Because what Tambun and his team are arguing is that roughly 45% of your adult moral capacity, your ability to be good, is biologically hardwired before you even finish first grade.
That is a massive claim. Between the ages of 3 and 7, that's the window.
That is the critical window.
So essentially, you're telling me my toddler's meltdowns over who gets the blue cup or my preschooler refusing to share a Lego. Those are actually high-stakes neural engineering events that will define who they are at age 40.
In a very literal sense, yes. The paper argues we aren't just learning manners in those years, we're building the physical infrastructure of morality.
Okay, before we get to the numbers, because the weighted model in this paper is wild, we need to understand the why. Why do the researchers isolate this specific age range, 3 to 7, the ECEC period, they call it? Why is this the magic number?
Well, it's not an arbitrary line in the sand. This specific window represents what neuroscientists call a period of peak plasticity for the prefrontal cortex.
Okay, let's unpack plasticity here. We hear that word a lot, neuroplasticity. Usually sounds like, a marketing buzzword for some brain training app.
Right, but here we're talking about the biological reality. The brain's ability to physically reshape its own architecture. Think of the human brain at age 3. It's absolute chaos. It has this overabundance of connections or synapses. It's like a jungle that's grown way too thick. It's dense, inefficient, and noisy.
So having more connections isn't necessarily better. I always thought more brain connections meant you were smarter.
Not for efficiency, no. Imagine trying to drive through a city where every street connects to every other street, but there are no traffic lights and the roads are all dirt paths. It's just gridlock. To work properly, the brain has to tidy up. And this leads us to the first major mechanism the paper highlights: synaptic pruning.
Synaptic pruning. It sounds aggressive, like landscaping with a chainsaw.
It is ruthless. It's a survival mechanism. Imagine a gardener with a pair of shears walking through that dense jungle of the 3-year-old mind. The brain looks at every single neural pathway and asks a simple binary question: is this one being used? If the answer is no, snip. It's gone.
So the use it or lose it cliche is actually a biological rule.
Literally. The paper describes it as eliminating weak or unused connections to strengthen the frequently used ones. Let's apply this to ethics. If a child has to practice empathy, say they comfort a friend who scraped their knee, that empathy circuit fires, the brain says, okay, this pathway is useful, we need this one, and it protects it.
And if they don't, if they're never in a situation where they have to share, or if they just get whatever they want immediately,
then the brain marks that circuit as inefficient waste. It prunes it. It cuts back the overgrowth to make the plant stronger. But if you cut the wrong branches, or if the moral branches never grew strong enough to be saved, you end up with a structural deficit.
That is terrifying. We are physically sculpting the brain based on what happens in preschool. But pruning is only half the story, right?
Yeah.
The paper talks about a second mechanism, myelination.
Right. Myelination. If pruning is the gardener clearing the path, myelination is the construction crew coming in to pave the road.
Paving the road. Okay.
Exactly. Myelin is a fatty substance that coats the neural axons. Think of it like the rubber insulation on an electrical wire. Without insulation, the signal leaks. It's slow, they're static. With insulation, the signal travels instantly.
And speed is the key here.
Speed is everything. The paper explains that this process stabilizes the circuits for executive function and fairness evaluation.
Fairness evaluation. I love that term. Sounds like a corporate compliance department inside your head. Excuse me, I need to file a report on that cookie distribution.
It's critical, though. When these circuits are myelinated, they become what the researchers call durable mental models. They shift from being something you have to actively think about, oh, I should share this, to something that's fast, automatic, and incredibly hard to change.
That's the reflex part.
Exactly. When you see that lost wallet, you don't stand there and weigh the pros and cons of Kantian ethics versus utilitarianism. You just act. That action is a biological signal shooting down a superhighway that was paved when you were 5.
So if that highway wasn't paved, if that circuit wasn't myelinated,
Then the signal takes the dirt road. It's slow, it hits resistance. And in the heat of the moment, the impulse to keep the money wins because it's the faster, more primal signal.
this brings us to a famous phrase the paper quotes, neurons that fire together wire together.
Hebbian learning, the golden rule of neuroscience. But I think this paper adds some fascinating nuance. They talk about something called spike timing dependent plasticity, or STDP.
Okay, hold on. Spike timing dependent plasticity. That is a mouthful. I need to break that down. What does that actually mean?
It sounds complex, but it's really about causality. It isn't just that neurons fire, it's the precise timing of the spikes. The brain is looking for cause and effect.
Give me an example. How does this look in the real world?
Okay, imagine a child hits their brother. The brother cries, the child feels a pang of distress or guilt. Those neurons are firing in a specific sequence. Action, consequence, emotion. If that sequence happens close together, within milliseconds, the brain says A causes B. It wires them together.
But if the timing is off,
If the child hits the brother and then 10 minutes later a parent comes in and yells, the brain might not link the hitting to the bad feeling. The timing is broken, the wiring doesn't happen. STDP is about the brain learning to predict consequences.
that actually explains so much about parenting, immediate feedback. And the paper mentions emotional tagging as part of this too.
Yes, synaptic tagging and capture. This is crucial. We don't remember everything. But when a moral experience, like the pride of sharing or the shame of getting caught in a lie, is paired with a strong emotion, it gets tagged.
It's like putting a high priority flag on an email or bolding the text.
Exactly. It becomes a privileged neural imprint. The emotion locks the lesson in. But here's where it gets a little scary. The paper discusses the danger of neural dormancy.
Dormancy, like a muscle you stop going to the gym for.
More like the muscle.
Right.
If those moral pathways, impulse control, empathy, fairness, aren't stimulated during that critical 3 to 7 window, they suffer from neural dormancy.
Mhm.
The paper is very clear on this. It leads to a physically weaker prefrontal cortex.
So fast forward 20 years. You're an adult. You're in a high-pressure meeting. You're trying not to scream at your boss. But if that impulse control circuit is dormant,
It is exponentially harder for you to resist.
yeah,
It's not that you want to be bad, it's that the braking mechanism in your brain is weak. Morality isn't a logic puzzle we solve as adults. It's a biological reflex. If the hardware isn't there, the software struggles to run.
that is heavy. It challenges the whole idea of free will in a way. And that leads us perfectly to the core of this deep dive, the weighted model. This is where the researchers stop just talking about biology and actually put numbers to it.
This is the part of the paper that really demands attention. They created a hierarchical model of ethical decision-making. They assign mathematical weights to what drives our choices. And as you mentioned, the numbers are not what most people would expect.
Let's run through them. Factor number 1, the big kahuna, early neural pathways.
Coming in at 0.45 or 45%, this is the dominant factor. This is the hardware we just discussed, the pruning and myelination. Nearly half of your ethical capacity is just biology.
Nearly half. Wow. Okay, so what's the next biggest chunk? Factor 2.
Factor 2 is cognitive biases. This accounts for 0.22 or 22%.
Biases. This is the brain playing tricks on us.
It's the brain prioritizing efficiency over accuracy. The paper mentions things like moral licensing. Do you know this one?
Oh, I definitely do this. I went to the gym this morning so I can eat a whole pizza for dinner.
Exactly. It's the internal ledger. In ethics, it manifests as, I stayed late to help a colleague yesterday, so it's okay if I fudge this expense report today. You feel like you've built up moral credit, so you spend it.
And the brain convinces you that this is fair.
It convinces you that you're still a good person despite the bad action. The paper also highlights loss aversion. We are significantly more likely to cheat to avoid losing something than we are to gain something. The pain of loss just overrides the ethical circuitry.
So 45% is childhood wiring, 22% is our brain being lazy. That's 67% of the decision already made. That leaves about a third.
And we haven't even hit the external stuff yet. Factor 3 is external pressures, weighted at 0.18, or 18%.
Situational forces.
Right. Authority figures, peer pressure, financial stress. The paper explicitly references the Zimbardo and Milgram experiments here.
The Milgram experiment, that's the one where normal people shocked other people just because a guy in a lab coat told them to, right?
Precisely. And this paper argues those experiments weren't flukes. They showed that authority creates a cognitive load that just overrides our values. If your boss is pushing for results at all costs, that pressure accounts for nearly 20% of your decision-making.
It's disturbing how easily we fold. Okay, factor 4 is context, 10%.
This is the specific environment. The classroom climate, the corporate culture. Is everyone else doing it? It's the broken windows theory applied to ethics.
And finally, we arrive at factor 5, the one that, frankly, hurts my ego. Character.
Character, 0.05, just 5%.
5%. I mean, come on. So what does this all mean? We spend our whole lives talking about integrity, about who we are in the dark. And this paper says that who we are is the weakest predictor of what we actually do.
It's a humbling finding. The argument is that character, our espoused values, what we say we believe, is a very fragile, high-level process. It requires energy. And when it goes up against the heavyweights, biology, subconscious bias, and external pressure, it just crumbles.
It's like trying to stop a freight train with a sheet of paper.
That's a very apt analogy. The train is your neural wiring and your biases. The paper is your character.
This feels deterministic, almost bleak. Like if I didn't get good pruning when I was 4, am I doomed? Am I just a biorobot acting out a script written by my kindergarten teacher?
Not doomed, but certainly disadvantaged. And this leads us to the solution section of the paper, because if we accept this model, it completely changes how we should approach ethics training.
Right. I've sat through those corporate ethics seminars. Here's the code of conduct, please don't embezzle. Usually involves a slideshow.
And the paper argues those are largely useless. They're reactive. They try to use adult logic to override 45% biological hardwiring and 22% subconscious bias. It's too little, too late. You can't lecture someone into having better myelination.
So what's the proactive approach? How do we actually move the needle?
We have to go back to the source. The 3 to 7 age range, the paper is very strong on this. Play is the training ground.
Play. Like recess. Tag.
It isn't just running around, it's neural engineering. Think about what happens in guided play. Let's say a group of kids is playing tag. Suddenly, one kid claims they were on safe base, and another kid disagrees.
High drama.
It is, but look at the cognitive demand. They have to negotiate rules. You can't be the lava monster twice. They have to share resources. They have to resolve fairness disputes without punching each other. They have to inhibit the urge to cheat.
So every time they do that?
Every time they negotiate a rule or hold back a punch, they are recruiting those executive function systems. They're forcing those specific neurons to fire and wire. They're building the highway.
That makes me look at a playground in a totally different way. It isn't a break from learning. It's the most important class of the day.
For morality, absolutely. The researchers argue that stripping away recess to focus on academic drills is actually stripping away the ethical gym that the brain needs.
But what about us adults? If my wiring is set, is there any hope? The paper mentions bias recognition.
Yes. Since we can't fully rewrite the wiring, we can't repave the highway. But the next best thing is to train the software to spot the glitches.
22%.
Exactly. Instead of just teaching values, we should be teaching people to recognize cognitive distortions. We need to train people to stop and say, wait, am I doing this because it's right? Or am I engaging in moral licensing?
Am I just doing this because I feel like I earned a cheat day?
Precisely. Or am I keeping quiet because of authority pressure? If you can spot the bias, you can interrupt the reflex. It takes effort because you're fighting your own biology, but it is possible. It's about creating a cognitive pause to let that 5% character kick in.
So we need to hack our own system.
Effectively, yes. We need to be smarter than our own brains.
This has been a massive paradigm shift. Let's recap this journey. We started with the wallet on the street and the idea that morality is a choice.
And we've moved to seeing it as a construct of early neural architecture. Synaptic pruning and myelination create the physical pathways. By age 7, the heavy lifting is mostly done.
We looked at the weighted model, 45% early neural pathways, 22% biases, 18% external pressure, 10% context, and a measly 5% character.
It forces us to realize that our ethical reflexes are largely set before we even learn long division.
So here's this so what for everyone listening. If you're a parent, obviously the takeaway is let your kids play. Let them fight over the toy and figure it out.
Guide them, but let the neural firing happen. Don't solve it for them. Let them feel the friction of fairness. That friction is the signal that builds the wire.
But for everyone else,
Yeah.
it's about awareness.
It is. It's about realizing that you aren't as in control as you think you are. When you feel that urge to cut a corner, don't just assume it's a character flaw. Recognize it might be a biological reflex or a cognitive bias kicking in.
And once you see it as a mechanism, maybe you can actually tinker with it.
Or at least pause it long enough for that 5% character to catch up. That 5% is small, but it's the only part that is truly conscious. We have to give it a fighting chance.
I want to leave you with a final thought today. It's a provocative one, derived from all this research. We cling to the idea of being good people. We wear it like a badge of honor, but
But if 45% of your moral capacity was determined before you finish first grade, and another 40% is dictated by subconscious bias and the pressure of the room you're in.
the question is, how much of your goodness is actually you? And how much is just biology and circumstance? Are we taking credit for a neural architecture we didn't build?
It's a question that might keep you up at night.
I know I'll be thinking about it the next time I see a lost wallet. Go out there, observe your own ethical reflexes in the wild, and see if you can spot the wiring underneath.
Thanks for listening to The Deep Dive.